Welcome back. Today we're going to be talking about one-sided and two-sided limits, and today we're going to be going over four multiple choice and also three long answer questions related to the AP Calculus course. So let's dive in. All right, so this first one asks us to evaluate this limit. Now you probably noticed right away that if we plug in 2 directly, we end up with a 0 in the denominator, which we can't have. And so it might be tempting to say, oh, well, then that means the answer is D, it doesn't exist. This is actually not the right answer, though. And here's why. Because it might be possible that we could simplify the numerator and the denominator together if we were able to find a common factor other than 1. So what I'm going to do is factor the numerator and the denominator and see if there's any common factors that we can cancel out. Now in this case, the denominator is actually already fully factored, so I'll just factor the numerator. Notice it's a difference of squares. And so therefore, we're going to have x minus 2 times x plus 2, like that. And then in our denominator, we're going to have x minus 2. Then I'll cancel these out, and we'll just have that the limit as x approaches 2 is going to go to x plus 2. And therefore, now I can actually sub it in and get 2 plus 2, which is 4. And so the correct answer is actually 4. Because it turns out that as x approaches 2, we approach 4 in terms of y. Now, is 2 comma 4 an actual point on here? Well, no, it isn't, right? Because if we plugged in 2 originally, what happens, right? We get something undefined. So there's actually a hole at that point, but it doesn't matter. Here we're just evaluating the limit as we approach 2 from either the left side or the right side. What would happen in that case? We're not actually asking for the evaluation, right? Because the evaluation would actually give us something undefined, as we discussed earlier. All right, now as always, if there's any questions, feel free to put those in the comment section. Let's move on to the next multiple choice problem. All right, so the next one asks us to find the value of the limit as x approaches 0 of absolute value of x over x. Okay, so here's the thing. Absolute value of x is essentially a piecewise function where f of x is equal to x whenever it's positive or 0, and it is the negative version of the original value in the event that we have a value less than 0, right? And so therefore what happens here? If I plug in 0 directly, we would get 0 over 0, which makes me think maybe it does not exist. And that actually is the correct answer. It is D in this case, for real. But let's talk about why it doesn't exist. Let's say that x is greater than 0. What happens in that case? If x is greater than 0, then we have x over x, which is 1, right? And what if x is less than 0? If x is less than 0, then we end up with positive x, because absolute value of a negative number would just be the positive version. So we have positive x over a negative number, and that's going to give us negative 1. Or actually, I guess I shouldn't really technically be saying, oh, it's negative x, right? Because x is going to be something less than 0. I guess I should technically be putting the minus up here, right? Because when I take the absolute value, then the sign does switch, right? But either way, whatever way we look at it, we're going to end up with negative 1 there. And so if we're approaching from the right, we're approaching 1. And if we're approaching from the left, we're approaching negative 1. And recall the definition of any two-sided limit is that if the right hand and left hand limit are both exist and are the same, then that is the limit. It's defined at that place. Whereas in this situation, they both do exist. The right hand and left hand limit both exist. They're 1 and negative 1, but they're not the same thing. And so therefore the limit just in general doesn't exist. All right, let's try a third example. This one says if the limit as x approaches c from the right is 5 and the limit as x approaches c from the left is 3, then what happens? Well, the thing is, that means the limit overall does not exist as x approaches c. Because recall, just actually we talked about this in the last one too, but recall that if the right hand limit and left hand limit are not the same, then that means the two-sided limit does not exist in that situation. They both would have to be the same in order for it to exist and to be that value. All right, and let's try this one here. It says that f of x is equal to x squared if x is less than 1, and if x is greater than or equal to 1, the limit is 3x minus 1. Okay, so basically what we want to know is as we approach from the left and from the right, do we end up with the same value? Because if so, then this limit does have a valid response. However, if we end up with different values for approaching from the left or the right, then we end up with it limit not existing. So let's say we're approaching it from the left first, okay? So that's where x is slightly less than 1. Then we would have x squared, which in this case would be 1 squared, which is just 1. Whereas for the right-hand limit, we plug in 1 to 3x minus 1, so we get that 3x minus 1 is 3 minus 1, which is 2. And so for the left-hand limit, we got 1. For the right-hand limit, we got 2. And so what does that mean? It means that the overall limit does not exist because we got two different answers. We would have had to get the same answer for the two-sided limit to exist there. All right, so now let's do free response questions. I have 3 free response questions, this being one of them just with part A, B, and C, so there are 2 more after this page as well. The first one asks us to evaluate the limit as x approaches 3 from the right. So the thing is, if x is exactly equal to 3, then what's going to happen? Well, we're going to end up with 0 in the denominator, which we can't have. So we're going to use something that is a little bit greater than 3, like 3.001, for example, because we're approaching from the right. So if I do that, I get 3.001 minus 3 over absolute value 3.001 minus 3. Well, in either case, we're going to get 0.001 and 0.001 since the absolute value of positive is just the number itself, and that's going to equal to 1. And notice that whatever we plugged in there that was slightly greater than 3 was going to have that exact same effect, right? Because let's say we'd done 3.0001. Well, we still would have got 0.0001 on the top and the bottom, so same thing top and bottom, and we still would have ended up with 1. Or what if we, gone further and done 3.1? Then we would have got 0.1 over 0.1, and same thing, we would have still gotten 1. So even had we chosen a different number that is slightly greater than 3, we would have got the same answer. Now, what about the left-hand limit? The limit as x approaches 3 from the left, right? This minus sign here means from the left, the plus sign here means from the right. Okay, so if we do that, I'm going to choose something very close to 3 as well, but approaching from the left. So maybe like 2.999. So let's do that. 2.999 minus 3 over absolute value 2.999 minus 3. Well, 2.999 minus 3, that's going to be negative 0.001. And then over here, we're also going to get negative 0.001. But in absolute value bars, that's going to actually become positive. So we're going to end up with positive 0.001 after applying the absolute value bars. And that's going to give us negative 1. And so what does that tell us? The right-hand limit and the left-hand limit are not the same. One's positive 1, one's negative 1. And so therefore, this one would not exist, right? Because by definition, in order for the two-sided limit to exist, both the left-hand limit and the right-hand limit must exist and be equal, and they're not. Okay, let's try this next one here. It says, consider the piecewise function where f of x is equal to x squared plus 1 if x is less than or equal to 0, and 2x plus 1 if x is between 0 and 2, and 5 minus x if x is greater than or equal to 2. So the first one asks about the limit as x approaches 0 from the left. We can tell it's from the left because of the little minus right there, approaching 0 from the left. Okay, so if we're approaching 0 from the left, we're going to be using this equation here, right? Because notice that this is for x being less than or equal to 0, and then for between 0 and 2, we have this new equation here, okay? So what that means is that if it was from the right, we actually would use this equation because although 0 isn't technically part of this interval, if we're approaching 0, getting closer and closer and closer to 0, everything even slightly above 0, like 0.00001, is in this interval. So if it was 0 from the right, we actually would use this interval here, because although this interval doesn't include 0, it still approaches 0 from the right. However, since we're doing it from the left for this first one, we'll be using the first equation here, the x squared plus 1. So for that one, we would have 0 squared plus 1, which is 1. So the answer here is just 1. Then for the next one, which is limit as x approaches 0 from the right, even though 0 is not part of the interval from 0 to 2, not including 0 and 2, we're still going to be approaching 0 in this one. And so I will still plug in 0 into the second equation for this question. So here we're going to have 2 times 0 plus 1, which is also equal to 1. In this case, because the left-hand limit and right-hand limit match, and they both not only exist, but they're both the same thing of 1, that means the limit as x approaches 0 in general is 1 and does exist. If these two numbers were different, or if one of these did not exist, then that would mean that the limit, the two-sided limit, does not exist, right? Recall that if we don't have a plus or minus here, that's referring to the two-sided limit, rather than either just the left or just the right. All right, there is a part D and E here. So for part D and E, it says, what is the limit as x approaches 2 from the left? So 2 from the left, even though 2 is not part of this interval here from 0 to 2, it's still approaching 2. So we're going to be using the 2x plus 1, which is going to be 2 times 2 plus 1, which is 4 plus 1, which is 5. So the answer to this one is 5. Then for 2 from the right, we're going to be using this equation here, the 5 minus x, because in this case, this is for 2 and above, so this is from the right. We would use this one. So that's going to be 5 minus 2, which is equal to 3. And so in this case, if they were to ask about the limit as x approaches 2 in general, the two-sided limit, we would say, oh, that doesn't exist, because we ended up with two different values for left-hand versus right-hand limit here. And the very last question here for today says to explain why the limit as x approaches 0 for 1 over x does not exist using the definition of a one-sided limit. So definition of one-sided limit says that the limit of as x approaches 0 from the right has to equal the limit as x approaches 0 from the left. Okay, so limit as x approaches 0 from the right would be, in this case, if we had something just a little bit above 0, like 0.0001, the smaller and smaller the denominator gets, the larger and larger the overall number gets. So this would go to infinity. Whereas if we did the limit as x approaches 0 from the left of 1 over x, we would get something as we get closer and closer and closer to 0 from the left side. We're getting like negative 0.1, even closer would be negative 0.01, then negative 0.00001, and then even closer. In that case, we're getting a further and further into the negative numbers overall, right? And so therefore, we would end up with negative infinity here, because it's the same pattern, except we have a negative, so negative infinity in that case. And so since these two are not the same, therefore the limit does not exist. The other thing I should add too is that they both are infinite, right? And so even if they were both positive infinity or something, we would still say the limit does not exist, because they can't be infinite. They have to be a finite number, and they have to be the same finite number as well. And so I'm going to say something like, since the values are infinite and not equal, that means that the two-sided limit does DNE, or does not exist. All right, well, as always, if you do have any questions, feel free to leave those down in the comment section, and we'll see you for the next one.